Okay, so there's lots of things you guys can do in here. You can chat in here. You can talk in here. Normally, I'm going to keep you muted, though, until you talk, until I want you to talk or something. But that way, we're not talking over one another, okay? Please enable.
Okay, I'm unmuted. Hello?
I hear you, Mitchell. Glad you can join us. Perfect.
Okay.
Well, it looks like we're only going to have about 3 or 4 of us. Oh, Alexis is going to join us, so maybe we'll have a few more of us. I don't know how long this is going to take. We're going to go over a worksheet that we got the other day, and that'll be it. So I know it's noon right now. I'm going to give people maybe 2 or 3 minutes to see if they can get on. Alec had a hard time trying to get his mic to work, so if anybody has any ideas how to make that happen, maybe you can chat in this box down here. You can chat to him, or hi all. You can type in it, and everyone hear me?
Yep, I can hear you.
Perfect, nice. I'm going to give everybody another minute. No, I can't hear you, Chris, but I can probably unmute you. Let me unmute you now, Chris. Do you want to talk?
Yeah.
Yeah. So I had everybody muted. The reason I'm muting everybody is because if I don't, then it'll sound like an echo chamber, and we don't understand. So I'll try to mute everybody, and then I will unmute you whenever.
Oh, okay.
Whenever we all need to talk. I think I'm going to start here in a second. So whenever we have snow cancellation days, we might do something like this where we'll whiteboard. So I sent you an email that gave you the homework. You probably got the homework done in class. But what's kind of cool about this is, let me show you some of the cool things you can do on here. So I'm going to come up here, and there's a tool right up here I can click on. This says voice the typing, and so I can click this. Now you have to be in Google Chrome. It won't work in Mozilla, but in Google Chrome you can click on this, and you'll start typing, or you'll start talking, and it will type whatever you're saying. So it's kind of cool. What's neat about it is that I've sent you an email to a whiteboard, a Google whiteboard, and it has the people in your group. So for instance, like Dalton and Chris are together, and they can actually chat on this thing and do things with it, you know, like answer the questions and stuff together. So it's not quite as good as if we were in class, but you know, it's not too bad. Can you guys still hear me?
Yeah.
Okay, good. All right, so do you guys want me to, I'm going to mute everybody. Do you want me to give you a little bit of time to work on your whiteboard, or do you just want to go over the answers? What do you want to do?
I'd go over the answers, because me, Medicine, I don't know about Aubrey, but we all got the stuff done.
Okay, so just go over the answers together. That's fine with everybody?
Yeah. Sure.
Yeah.
Okay, we'll be done a lot quicker that way too. All right, okay, so I'm going to mute you guys, and then we'll just, actually, I'll keep you unmuted. That way we can just kind of talk about this. So can you guys still see my my computer screen when I go like this?
Yeah.
Yes.
Yeah.
Yeah.
Okay, so this first one says in the following circuit, which bulb lights up first? What's the answer here? A, B, C, D, or E?
D.
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 Perfect. Nice. Yep, it's D. And what's the explanation? Why do they all light at the same time?
Because everything's connected.
Does everything connect?
That's right.
Yeah.
Yep, it's a closed conducting path. Right. Nice. So I think I can even type that in here. It is a closed conducting path. There you go. Okay, let's look at the next one here. Number 2, it says for each loop, state which bulbs light. So for number 2 here, which bulbs light here?
None.
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 Nice. So I'll go ahead and type it. None. None. Okay, what about in circuit 2 here? Which bulbs light up?
A.
A.
A. A.
A. Okay, that didn't work. All right. All right. Okay, technology. Okay, what about in this one here? Which bulbs light up?
Both of them.
Both.
Both. Both.
Both. Nice.
Can you guys hear me?
All right.
Yeah.
Yeah.
Perfect. Perfectly. Nice. Nice job. Okay, for number 3 here, it says study the 2 circuits. Which of the following statements is true? A, the bulbs will light more brightly in circuit A. B, more brightly in circuit B. C, the bulb brightness will be the same. Or D, the bulb will not light. Which one's the answer?
B.
C.
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 Okay, I'm hearing B and I'm hearing C. Say it again.
C.
C.
C. I think most people said C. You're right. It is C. It's not B. It's C. C. Okay. Oh, I'm going to mess that up again. Okay. The reason why it's not B is that paperclip is a conductor, and it doesn't matter where you put it in the circuit, you're going to have the light bulb go on, and it's going to be the same brightness.
Yeah.
Okay, number 4. Number 4, explain why you believe your answer in number 3 is correct. Oh, well, we just talked about that. Use terms insulator and conductor. Yeah, so that paperclip is a conductor. So I'm going to put that here. The paperclip is a conductor. The bulb will come on regardless. Okay, number 5, write in your own words a definition of the word circuit. So, does somebody have an answer for this so I don't have to tell you the answer? Let's hear somebody's definition.
A circuit is the wires used to light up a bulb.
Perfect. And what does it have to have in it? Battery.
Wires.
Right. It has to have a battery. Okay. What? Wires, battery. Okay. So a circuit is used to light a bulb and must have wires and a battery in it. Make a closed conducting path. Okay. Any questions on that one?
No.
No. You guys are doing great. Doing great. Okay, number 6. We have observed in several activities that as soon as a very small gap is produced anywhere in the circuit, the bulbs go out. So would you classify air as a conductor or an insulator?
I chose insulator.
Insulator? What do you guys think? All insulator?
Yeah.
Insulator.
Yeah.
Right? And why insulator? You're right. You're right.
Because it doesn't have metal in it.
Okay. So, and the bulbs don't come on.
Yeah.
Right. Air is an insulator because the bulbs don't light. And that's supposed to be light. Okay, so any question?
No.
All right.
No.
These are the hard ones, so let's make sure we understand these. Okay, indicate whether each of the following statements is true or false, then state evidence. Okay, so number 7, charges move out of each end of the battery in the loop. What do you guys think? True or false?
False.
I think it's true.
False. The answer is false. That's right. So false. False. And what's your evidence? How do you know it's not moving both directions in the circuit? How do you know it's only moving in one direction?
The compass moves out.
Perfect. That's right. The compass was pointing in the same direction for all the wires. The compass points in the same direction for all the wires, period. Any questions on that?
No.
Okay, this is going to be a really good study tool for the test tomorrow. You need to know this stuff. So if you have any questions, please interrupt me and say something. Okay. Part B, it says light bulbs are non-directional. What that means, non-directional, means whichever way they're connected in the circuit, they behave the same way. They turn on. True or false?
True.
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 Nice. True. True. That's right. True. And sorry about the phone. Maybe somebody will answer. Oh my gosh. Sorry. Okay, so what's the evidence that no matter how you hook them up, they still work? What did you guys see? Yeah, go ahead.
I'm guessing we might have saw, move on to
Well, do you guys? Well, do you remember when you were hooking up and you're trying to make one light bulb
Hooking
light
up
up
the wires?
with just a wire and a battery?
Yeah.
Yeah, remember that? And
Yeah.
then you tried to do 2 light bulbs and 3 and 4. Did it matter if you touched the threads with your left wire and the tip with the right wire, or could you flip that around and have the right wire touch the threads and the left wire touch the tip?
Both.
You can do both, right? Yeah, so I'm going to put that in here. The evidence was that when I observed in lab, I could connect it either way and it still worked. Period. So does that make sense?
Yeah.
Okay. Next one. The battery determines the direction of flow of charge in a circuit. True or false?
True.
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 Yep. True. 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 And what's your evidence of that? What did you see that the battery was able to affect the direction?
Because when we flipped it, it didn't work. Yeah.
So wait a second. When you flipped the battery, it didn't work?
Like the battery pack. Battery packet around.
Yeah. So what happened, though, when you flipped the battery pack? What did you see? What happened to the compass needle?
Went the opposite direction. It went the other way. It went the other way.
That's right. Exactly. That's it. So I'm going to go ahead and put that down then. When I flipped the battery pack, the compass needle flipped the direction. Period. So again, this is going to be a really good study tool. I'm actually recording this. I hope I am. Yeah, it is recording.
It is recording.
So you can go back and watch this. Yeah, you can watch this video later on if you want to. Okay, the next one. A compass can be used to determine the exact direction that charge is flowing in a circuit. So can you tell from the compass the exact direction that the charge is flowing? What do you guys say?
False.
Good. False. Good. False. False. Do you guys remember the evidence for this? This was a hard one. How do you know that's false?
Because when we did the lab, it didn't go straight. It went either left or right.
Oh my gosh. Genius. Mila, was that you? Oh, now she's quiet. That's exactly right, because my AP students always mess that up. Yeah, it's because the compass needle doesn't point along the wire, it rotates away from the wire. Nice, I'm going to put that down. Compass does not point along wire, it rotates away from wire, period. Okay, the next one. Metal substances are generally conductors.
True.
True.
True. Yep, true. True. And what's your evidence?
I
Think about what they did. Yeah, the light bulbs
light up.
Yeah, exactly. That's exactly it. When metal was used, the light bulbs turned on. Nice. Okay, so we only have a few more and we're almost done. Okay, so number 8. So these students were connecting this circuit up and we're supposed to draw a continuous conducting path. So I'm going to have to do this one, I think. Uh-oh, can I... Hold on a second here. Sorry about this. Let's see here. Insert drawing. Okay, so I'm going to go ahead and start drawing this. I'm going to use color if I can. That's why I like this. This is actually kind of fun if I can figure out how to turn the color on. Scribble. I thought I could turn color on this one. Where's color at? Well, I can't get it to work. Alright, so I'm going to, well, maybe. Oh, there's the color. I knew there was color somewhere. Okay, I'm going to try to draw it in red here. Okay, so I'm not doing a very good job. I'm going to stop as soon as I get to the tip here. And I need you guys to tell me, how does it go now? I'm going to keep on drawing.
It goes into the thread.
Right, it goes, well, it doesn't go in the thread, it goes to the tip and it goes up the support wire here. Okay, I'm going to see if I can make this. Right, then it goes across the filament. Okay, then what?
Down the support wire and through the thread.
Yeah, down through the threads, into the threads of the other one, then what?
Go up to the support wire.
Perfect. Let me see if I can draw it. I can't quite draw it. Nice. And then across the filament, and then down the other support. Yeah, and then out the tip.
Yep.
Out the tip. Okay, so you need to be able to do that on the test. Okay, so I will save that so you can come back and watch the video there. Okay, so we only have 2 more. All right, so number 2 here. Which of these light bulbs come on here?
I said both.
Good. What about the other people? Yeah, both of them. They both come on. In fact, let me see if I can... Oh, shoot. Okay, so hold on a second. I'm going to see if we can draw the continuous pathway again. Drawing. Okay, let's see if I can draw this again. So it gets to the tip. I'm going to color red so we can see it better, a little thicker. Okay, then it goes up the support wire, goes across the filament, down the other support wire to the threads, into the other threads, up the support wire, across the filament, down the support wire, and out the tip. So I agree, it has both of them light up. Nice. Okay, let's do the one right over here next to it. Which of the bulbs light up here?
Both.
Both.
Yep, I agree. I think so. I'm going to see if I can draw it. So then it goes up the support wire, across the threads, down the other support wire, out the tip, up the support wire, filament, threads, and all the way around. Okay, So there's both of those pictures, and let's see now if I can put the answer in here. So we said both light up. So I'm going to say light. 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 Okay, any questions on this worksheet?
No.
No.
Okay, so you guys are ready for a test. We're having a test tomorrow. So you remember yesterday's Flex Day learning? If you didn't get it, if you didn't get mastery, you really should do it again. You should probably email me and I'll open it back up for you. So that's it. You guys did a great job. I really appreciate you doing this. And I look forward to seeing you guys in class tomorrow. That's it. Nice. Okay, so you guys can go ahead and leave unless you have questions for me. See you guys tomorrow.